Welcome to this video lesson about the Cartesian plane. We will be learning about plotting points and drawing shapes on a coordinate grid. Now, I want you to imagine a number line. It has 0 at the middle, and it's got negative numbers extending to the left and positive numbers to the right, just like this one. We're quite used to plotting numbers on number lines that look like this. And in fact, we've been using them a lot recently as we learned about positive and negative integers. Now, take a second and imagine a second number line perpendicular to the first one, so a vertical number line. These two number lines cross at 0. We call this a coordinate grid or a Cartesian plane. Now let's find out why that strange name. Well, it is named after this guy, Rene Descartes. And if we look at his name, the last part of his name here, Descartes, and you just put the suffix "ian" on the end of that, oh, big N, you can see it spells out the word Cartesian. So we name this kind of grid a Cartesian plane. So, who was Rene Descartes? Well, he was a French mathematician who lived from 1596 to 1650, a long time ago. He developed the coordinate system that we're going to be learning about as a way to show how algebra could be used to solve problems of geometry or geometric problems, which was a whole new way of thinking and kind of revolutionized the world of mathematics at the time. So it is in his honor that we call it the Cartesian plane. Descartes is often called the father of analytical geometry as a result of the work he did to link algebra and geometry. Remember, he said that you could use algebra to solve a geometric problem. He is equally famous, though, as a philosopher, and he's also known as the father of modern philosophy. And those of you who go on to study math or history or philosophy or any of the humanities in university, I guarantee you 100% you will be learning a lot more about Rene Descartes in your future education. One of the things he's most famous for is saying that we should doubt everything until we can prove it. And for this, he is seen by many as having originated the modern scientific method. So Descartes said, nothing is certain, doubt everything. This is sometimes also known as skepticism, being skeptical of things until you can prove them using logic. There was one thing, though, that Descartes said we could be certain of despite this skepticism, and that is the fact that we exist. And he thought, because if you can ask the question, do I exist? Then that proves that you exist, or else you wouldn't have a mind capable of asking the question. So if you don't exist, you wouldn't have a mind capable of asking that question, do I even exist? So he is very famous for coming up with this saying, I think, therefore I am. You may have heard it. You definitely will hear it again in your life. Descartes gave us the coordinate grid system we use in math, in mapping, and even in Minecraft. He's also the father of modern philosophy, and he gave us the scientific method with his Cartesian doubt. Boy, we sure owe Descartes a lot. All right, let's look more closely at the Cartesian plane. When we say plane, we don't mean an airplane that flies around in the sky. We're using the word plane in the mathematical sense, which means a flat, two-dimensional surface that extends infinitely in all directions. So it just continues to go on forever and ever in all directions. You can sort of think of it also like a piece of paper, okay? It is a flat surface. Imagine an infinite piece of paper, but it's thin. It actually has no third dimension whatsoever. So imagine how thin a piece of paper is, but actually so thin that it doesn't have any thickness at all. And you'll have some idea of what a plane is. Okay, so the Cartesian plane consists of a set of two lines intersecting each other at right angles. And we talked about our two number lines that we visualized, one horizontal and one vertical, that were perpendicular to each other, intersecting at a right angle. So we call that the Cartesian plane. All right. So our Cartesian plane consists of a number of different parts. That horizontal number line that we started with at the beginning is our x-axis. There we see our horizontal number line. We call it the x-axis. The y-axis, or the vertical axis, is that number line that intersects our horizontal number line at a perpendicular, a 90-degree angle. So when those two number lines cross, they split the plane into four squares. And we call these squares the four quadrants of the Cartesian plane. So a quadrant is the region formed by the intersection of the x-axis and the y-axis on the coordinate plane. We numbered the four squares of the four quadrants like this using Roman numerals. So this is quadrant 1. And this is actually the only quadrant that we are going to be using for the rest of our unit. In other years, you'll get to explore quadrants 2, here indicated by the Roman numeral 2, quadrant 3, which is all negative numbers because we have negative on the x-axis and negative on the x-axis and negative on the y-axis. And the fourth quadrant of the Cartesian plane represented by Roman numeral 4. And I sure hope that those Roman numerals are familiar to you from hopefully grade 3. All right, so this is our Cartesian plane. We have an x-axis that goes horizontally from left to right. We have, let me mark that there. This is our x-axis. We're actually going to clear that because we can't draw a straight line this way, but we'll just mark it as our x-axis. And we have our y-axis, that is the vertical axis that goes up and down. Both axes, axes is the plural of axis, both axes extend infinitely in both directions. So that's why we represent them with these arrows at the end. And then we have our four quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we remember that we are going to be focusing on only quadrant 1 for the rest of this unit. Okay. Let's think back to our number lines crossing at 0 again as we look at this image, because this is what really defines a Cartesian plane. We call the point where the two lines cross the intersect, which makes sense when you think about a road and where two roads cross and you have to cross the street. We call that an intersection. So we call this here the intersection where those two lines cross. And we call the point where they cross the origin, which we mark with an O, which is really hard to tell apart from a 0 because they both look the same. So the point where our 0 is, where those two lines cross, is called the origin. And here's an arrow pointing to the origin for you. Let's take a closer look now at how to plot points in quadrant 1 of the Cartesian plane. Let's clear that selection first. So, plotting points on a coordinate grid. Okay. From our origin to reach point A, we have to move 5 units right and 3 units up. So we write these numbers, 5 and 3, in brackets. And just a point, we always move right along the horizontal axis and up along the vertical axis. So you can see that those arrows indicate the direction of movement, but they also indicate that that line carries on infinitely. So here we go. We moved 5 units right and 3 units up to get to point A. So we write that number in brackets as 5, 3. These numbers are called coordinates. So we can say point A has coordinates 5, 3. And because the coordinates are always written in the exact same order, we also call these coordinates an ordered pair. So that's a really important vocabulary word for you to know, ordered pair. So to mark point A in our coordinate grid, we write A bracket 5, 3. That tells us that point A is located at 5 on the x-axis and 3 on the y-axis, or that we have to move 5 units to the right and 3 units up to reach 0.53. We don't go up to, where's my pen? Here we go. We don't go to 5 first and 3 second. That point would be actually 3, 5. As you can see, it's a much different point than our actual point A. So we got to be careful that we don't get those mixed up. The first number always tells you how far you move right, and the second number always tells you how far you move up. That's a little quick review there. Okay, when the numbers in an order pair are large, we use a scale on the coordinate grid, and you can see that is represented here as 1 square equals 5 units. This is our scale. So we can see here, if we go down and look at it, when we move 1 square, we're actually at number 5. I probably should have put that this way. To go from 1 square, we've moved 5 units. 2 squares, we've moved 10 units. 3 squares, we've moved 15 units. Okay, so these numbers are indicated on the axis, the x and y, but we're also reminded of it up here. Okay, so to reach point B, or what we call plotting point B, where we draw B on the grid, we have to start at O, the origin, otherwise known as 0, but it's best to refer to it as the origin. We move 2 squares right, because that takes us 10 units, 5, 10. And our coordinates, our ordered pair, tells us that we have to be at 10. And then we're going to move 6 squares up, because 6 times 5, and we know our scale is that 1 square equals 5 units. 6 times 5 makes 30. So to get to 30, we move 6 squares up. Now it is your turn. Match each ordered pair with a letter on the coordinate grid. So here's the coordinate grid. Here are the letters. And you're going to take a moment to note what the coordinates are, or what the ordered pairs are for each of these points. So find point A, look at it, and decide what the ordered pair or coordinates of A are, and then do the same for B and C and D, and you'll answer this question right now. All right. When you finished answering the questions, take a second, take 5. Get up, stretch, drink some water, do whatever you need to do to clear your head and get ready to forge ahead with part 2, drawing shapes on the coordinate grid. All right, we can use ordered pairs to describe the position of a shape on the coordinate grid or the Cartesian plane. To describe this rectangle, let's make some space so we can see it here. To describe this rectangle, we label its vertices with letters. Now remember, vertex is corner, vertices is the plural of vertex. So we have 4 vertices and they are labeled each with a letter, A, B, C, and D. The letters are written in order as you move around the perimeter of the shape. So they go in order A, B, C, D, not A, B, C, D. We then use coordinates to describe the location of the vertices. So we can use ordered pairs to describe the position of this shape on a Cartesian plane. And hopefully this reminds you a little bit of our Monday math challenge. And maybe if we had known what we know now, we might have been able to find that task just a little bit easier if we could have used ordered pairs to describe the location of these shapes on the Cartesian plane. So point A has coordinates 4 and 6. You can see 6 is halfway between 4 and 8. It's clear that our scale here is that each square represents 2 units. Point B has coordinates 4, 18. Point C has coordinates 20, 18. And point D has coordinates 20 and 6. How can we find the dimensions of a shape on a coordinate grid? Now, remember that the first coordinate of an ordered pair tells you how far you move right. So we can find the horizontal distance between D and A by looking at the first number in the ordered pair for each point to find the width of the shape. So how can we find the dimensions of shapes on a coordinate grid? Well, remember that the first coordinate of an ordered pair tells you how far you move right. So we can find the horizontal distance between A and D by looking at the first number in both ordered pairs, because that's telling us how far we move right on the horizontal axis. So to find the length of this rectangle, we can look at the difference between 4 and 20. That's the first number in each set of ordered pairs. 20 minus 4 equals 16. So we know that the rectangle is 16 units long, or it has a length of 16 units. Now, let's do the same for the width. Remember that the second coordinate of an ordered pair tells how far we move up, and that's indicated in red here. So similarly, we can find the length of this shape by finding the difference between the second number in each ordered pair, 6 and 18. 18 minus 6 equals 12. So we say that this rectangle has a width of 12 units. Of course, another way to do it is just counting the squares. There's 8 squares along the horizontal segment AD. So we know that each square represents 2 units. 8 times 2 equals 16. So the playground has a length of 16 units. And when we count upwards on segment AB, we know there are 6 squares when we count. Each square represents 2 units. 6 times 2 equals 12. So the playground has a width of 12 units. All right, now it's time to plot points on this grid right here and make a shape. I did say we were going to be drawing shapes on a coordinate grid. So go for it. Well, actually, let's do it together. All right, let's draw this shape together. You can see I'm using a page that I've already drawn on, and that's okay. We don't want to waste paper. We want to make the best use of our paper possible. So I have some space here, and I'm going to use this space to draw my shape. So I've started off by copying down all of my points, A, B, C, D, E, and F, along with the ordered pair that goes with each point. Now, let's draw our coordinate grid together. We know we need to go from 0 to 30 on the x-axis and also on the y-axis, our horizontal and vertical axes. We're going to start at 0 at the origin, and each square represents 5 units. So I need to make sure that I have a space that can go 6 in one direction and 6 in the other direction. So that's actually going to be a pretty small graph, but we can do this. So if I start at the very top of my y-axis with 30, and then I move down, my next point is 25, 20, 15, 10, 5, and 0 at my origin here. Then I'm going to do the same, moving along the x-axis, 5, 10, 15, 20, 25, and 30. Now you don't have to start at 30 and work backwards. I just did that because I knew that's where I wanted the top of my y-axis to be. Now, notice that I am writing my numbers on the lines, right on top of the lines. I'm not writing them in the space in between. That is tempting to do, and it might seem to make sense, but we definitely want to write right on the line because we know 5 is on this line. So we need to write our numbers exactly on top of the line. Let's use our ruler now to draw a straight line. So we place our ruler down. I actually like to put my pencil where I want it to be and then put my ruler right up to my pencil because that helps me get it right on the exact line that I want. And now I'm going to start and go right up to 30. Now I'm holding down, pressing down hard on this ruler so it stays in one spot, and I'm making a nice dark line. I'm going to now move and do the other line. I'm going to start with my pencil exactly where I want it to be. Make sure that my ruler is lined up very straight. I know where to stop and draw my straight line all the way. Now, if I drew a little bit past 30, that would be okay because we know that these lines do extend off in both directions infinitely. All right, now let's begin plotting our points. So we're going to start with A, which is at 10 and 5. So remember, our first number in the coordinate pair, our first coordinate tells us our x-axis or our horizontal location. So we want to go to 10. And then the second number tells us our y-axis or our vertical location. So we'll go over to 10 and up to 5. We're going to make a dot here and we're going to label that point A. Our next ordered pair for B, point B, is 5 and 15. So this time we're going to go right only 5 and up 15. And we will make a nice point there and label it point B. Next, point C, the ordered pair is 10, 25. So again, we go over to 10 and this time all the way up to 25 where we make our point and we label it point C. Next, point D is at 20, all the way over to 20 and up to 25. Make a nice point, label it D. Point E, the ordered pair is 25 and 15. We make our point, label it E. And the last point, F, the ordered pair is 20 and 5. We go over to 20, up to 5, make our point, and label that F. So now we have plotted all our points on the coordinate grid. The next step in the instructions said to join all the points starting in order. So we're going to go A to B. Now again, I put my pencil down, I line up my ruler, I hold that ruler down. I don't want it to slip around while I am tracing out my straight line because I want my work to be very neat so that the teacher can see that I've done my work correctly. From A to B, next step will be from B to C, from C to D, from D to E, from E to F, and then the final instruction said to join point F to point A with a line segment. So I'm going to do that as well. And now I have drawn a beautiful shape. The last part of the question says to describe the shape that you have drawn. And that part I'm going to leave to you to complete independently. Thanks for working on this shape with me.